diagrams. You could use your knowledge of compound events as well, but in the end, they wanted to show displaying of the tree diagrams. So for the very first problem, situation A, it says that Ms. Sharp is planning a dinner party. Well, the entree is going to be roast beef, so there is no other entree choice. That means that the main trunk of the tree is just one item. That's why they only have the one item written here, roast beef. There are choices for carbohydrates, right? You've got a mashed potato as a choice, baked potato as a choice, or noodle is a choice, so a carb of some sort. So you have 3 branches that are coming out from roast beef, and then from each of your carb choices you get 1 choice of a vegetable. You could have broccoli, spinach, or carrots. So from each of our carbs we've got 3 little twigs that are coming out from each of them. Okay, so they've already built the tree diagram for you. They just wanted you to utilize that tree diagram to identify true or false. So for the very first one, it says there are 13 possible meals that she could serve. If you count the total number of twigs that you have in that last column, that'll tell you how many total possible outcomes you have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 twigs. 9 little small itty-bitty branches that are coming out at the very end of that tree diagram. So that means that this is a false situation. You only have 9 possible outcomes, not 13. For number 2, they said the probability of eating a meal with noodles and spinach. Noodles and spinach is going to be 1/9. There's only one possible section that's going to be noodles and spinach, and that's located right here. That you could have noodles, spinach, that's just one possible location out of the 9 total that we located here. So that statement is true. And then according to the tree diagram, you could have roast beef, broccoli, and carrots. Is there any way that we could have both broccoli and carrots? No. You have to only have one vegetable as an item. So that's a false statement. All right, for problem B, Michigan State's football, they're talking about the different kinds of uniforms that they could wear. They've got 3 colors for jerseys and 2 colors for pants. You could do green, white, or striped for your jersey, and you could do either green or white for the color of pants. So we create the tree diagram. They even let you know, hey, you're going to list your jersey colors first, and then the pants are going to come second. So this is what the tree diagram should look like. You should have 3 items in your trunk, and you should have 2 branches coming off of each item. Okay, so here is the total possible number of outcomes. If you count, we have 1, 2, 3, 4, 5, 6 sections here, or 6 final twigs or branches here. So that's the 6 possible outcomes. This is the listing of the outcomes. You could have green jersey and green pants. You could have green jersey, white pants. You could have white jersey, green pants, white jersey and white pants, striped jersey and green pants, or striped jersey and white pants. And then the probability that you're going to wear a jersey that is white, wearing a jersey that is white, means that we could go ahead and go here. That's one option. We could also go here. That's 2 options. We have 2 total options that we could do. White jersey with green pants, white jersey with white pants. 2 total options out of 6, which simplifies to 1/3, or 0.3 repeated, or roughly 33%. Okay, for problem C, you've got different bicycle options based off of the color of the bike, the color of the trim that goes around the tire, and then the size of the tire. So I showed 2 ways that you could find the total number of combinations, because they actually did not tell you to build a tree diagram, but they gave you so much space that that's probably assumed is what they wanted. But there's 2 ways you could have gone about it. You could have identified that there are 3 colors, 2 trims, and 2 tires, and if you multiply those, you'd get 12. And then if you map it out, you've got your 3 colors. Each main color has 2 trims coming out for it, and each trim has 2 tire sizes coming out for it, for a total of 12 twigs that we've got here in our tree. Okay, problem number 2, they want the probability of getting a tire that has a silver trim, and a 24-inch tire. So a silver trim and a 24-inch tire. We've got that here where it's red, silver, and 24-inch. We could have green, silver, and 24-inch, or we could have a black, silver, and 24-inch. So there are 3 possible ways out of the 12 total outcomes. 3 out of 12 is the same thing as 1/4, and 1/4 converted to a decimal, because it's asking for it as a decimal, is 0.25. Okay, and then the probability that owning a bike with a black main color, a trim color of white, doesn't have anything to do with the size, doesn't have anything to do with the size of the tire. So I'm actually going to do this one in orange here, or no, we'll do green. We'll use green. So a black main color with a trim color of white. So we're focusing here on black and trim of white. So we have black, white, and 24. We also have black, white, and 26. There are two total ways that we could achieve that outcome out of the 12. 2 total ways that we could achieve that outcome of 12, which is 1/6, converts to 0.1, and the 6 repeats. And since they want it as a percentage, it comes out roughly to 16.7%. Or you could say 17. You could say 17% is perfectly fine as well, approximately. Okay, flipping on over to the back, guys. This is the last problem that we're going to do. For problem D, they give you a table format of information. So size of pizzas, type of crust, and the type of toppings. So here's what your tree diagram should look like, smalls and large. Each of your sizes has 2 branches coming out for the crust, and each of the crusts have 3 branches or twigs coming out for the options of toppings. So this is what your tree diagram should look like. It has 12 total possible ways to order a pizza. They said list the possible outcomes for a large pizza only. So we're going to ignore that top half and focus only on the large outcomes that we could have. We could have large thin crust with pepperoni, large thin crust with mushrooms, large thin crust with ham. We could have a large regular with pepperoni, large regular with mushrooms, and large regular with ham. So there's 6 total ways that we could order a large pizza. Okay, they want the probability of choosing a pizza that has thin crust and pepperoni. So it has to have both. The key word and means that it must have both. Both must happen at the exact same time. So if we want thin crust and pepperoni, we could do a small thin crust with pepperoni, or we could do a large thin crust with pepperoni. That's 2 outcomes out of the 12, which simplifies to 1/6, or about 16.7%. Okay, the next question is an or. The next question is an or, which means it could be this or that. It doesn't have to be both at the exact same time. It just has to be one of them or the other. So those are different. Or is different than and. And has to happen together, or can still be individually. Okay, so mushrooms or ham. So we could have a small thin crust with mushrooms. We could have a small regular crust with mushrooms. We could have a small thin crust with ham. We could have a small regular crust with ham. We could have a large thin crust with mushrooms and a large regular crust with mushrooms, or a large thin crust with ham, large regular crust with ham. So what we did is we identified 8 total possible outcomes of mushroom or ham out of the 12, which simplifies to 2/3, or roughly 66.7%, or 67%, depending on how you go about rounding. E, I'm not going to worry about checking that because everyone's going to have something different. The idea of that is just to have you thinking, okay, what's something that I could do that has 3 different options? We've gone over problems like that even yesterday. Yesterday we talked about it where your closet. You have different shirts, different pants, different shoes. Okay, so there's different kinds of stories that you could come up with. For a bonus activity or a bonus credit in your assignments, if you would like to turn yours in online tonight through Google Classroom, you can attach yours and submit it, and then I'll look over it. If it's correct, you'll get an extra credit assignment put into the gradebook. If you don't do it, it's not going to hurt you. Okay? Questions? Fantastic. If you can go into Google Classroom at this time, the quizzes has been loaded